Welcome back, concept getters. I hope all of you are good, and we are going straight to the concept because I don't want us to waste any data and time. You know why? Because this concept is very long. As you can see on your screen already, we have two columns for values and variables. The variable section is the one that you're going to present in the exam. That's what they would be asking from you. And with values is just for me to make you understand and see things happen with real values. Do I make sense? So they want us to prove the formula for the arithmetic series, which is Sn equal to n over 2 all into 2a plus open bracket n minus 1 close d close, right? So with values, I'm going to write a series in numbers, and then with variables, I'm going to write a series with variables, meaning it's going to have a and d, right? And I'll also show you where the terms in the series with variables come from. And then with every time when I do with value, I'll also do with variables so that you understand, oh, this is how it works. Oh, when I divide, that is why I divide. That is why you get the point, right? But let's just go straight to it because I'm not here to preach, but I'm here to explain and simplify and. With values, let's say we have a series. Let me just enlarge a bit and say, then I'm going to write with values. When I say with values, we have, let's say we have sum of, let me just say 8 terms, right? Let's say sum of 8 terms is equal to, then we have 2 plus, should I make it 4? No, let me make it 5. So let's say 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23. 8. Okay, there are 8. Then I'm going to say the sum would be what? The sum of 2 plus 5 plus 11 plus 14 plus 17 plus 20, then 17, which is plus 23, is going to give us 98, right? So it's going to give us 98, right? So if we have terms like this, and then we're going to prove, see what's going to happen with the variables. I'm going to create the same terms, but I'm going to only write the first, second, and third. And then here it's going to be, then it's until here, then I'm going to say this and this and this. So I'm going to write only the first 3 and the last 3 when it comes to variables. Let me show you how it's going to be done. It's going to be, then we move and this way, right? So with variables, we're going to have something of this kind. We're going to say S of n, that's the first step you're going to do, is equal to, according to the number patterns, arithmetic pattern, right, linear, the first term is always a, right? So I'm going to say a, that's the first term. And according to arithmetic's linear pattern, not arithmetic linear pattern, because they're the same thing. Arithmetic pattern, according to it, the second term, in order to get the next term, you add d onto the previous term. So which means I'm going to say this a plus d is going to give me the next term, right? So it's going to be what? It's going to be a plus d, right? And then I'll say plus to get the next term. In order to get the next term, I'll take the previous term and add d, because d was the difference. Do that make sense? The same way I was doing when I was here, from 2 to 5, I was adding 3. From 5 to 8, I was adding 3. Do that make sense? D is the constant difference. So on that other pattern, our d is just d because we don't have the value, right? We're dealing with variables. But on with values, we're dealing with numbers. So we know our difference is 3. That makes sense, right? So let me go back. Right? So I'm going to say I'm going to add d to get the next term, right? So we're going to have a plus d, then plus d. Same variables, like terms. You just add the coefficients. Then it's going to be a plus 2d, right? Which is going to be a plus 2d. Then I say this. Then I will say dupu, jupu, jupu plus. In the middle there are infinite number of patterns because our n, instead of writing 8, we don't know if it's 8 terms. It's just the number of terms, right? We don't know how many terms we have in this pattern because it's general. N can represent 8, it can represent 20, it can represent any other number. So that's why we're going to say 3 dots in between to show you that there are infinite number of terms within the whole pattern. Do that make sense? And then we're just going to write the last 3 terms. So with the last 3 terms, I prefer writing the last one and then write the penultimate one and then the second last. Do that make sense? So basically, I'm just going to be like Vutu, and I'm going to write only the last one. And then in order to get this one, I'll show you how. And in order to get this one, I'll show you how. But let's go first to the numbers so that you see what was happening for us to get those ones. We're going to be like, look. When you look at this pattern, guys, you can see that if 23 was my last term, in order to get the previous term, I said 23 minus 3, which is 20. And in order to get this one, I said what? 20 minus 3, which was 17. So you see, I take the last term, I minus D. D was 3, right? I minus D to get the previous. Again, I minus the constant difference to get the previous. That's how it works. So even with that other pattern, it's going to be the same thing. We just subtract D. But then the question is, how did I get my last term with that other one? The last term in any pattern is just the general term, which is Tn. So let me show you. So let's say the last term, guys, is just going to be Tn. What is Tn? Tn equals to A plus n minus 1 into D. That is going to be the last term. So let me show you. So if that's the last term, I'm going to write it. I'm going to say, open bracket, A plus n minus 1 into D. Then I close with square bracket. That's my last term. How do I get the term that comes before the last term? In order to get this one, I'll take this one and subtract D. So let me show you how it's going to be gotten, okay? I'm going to say, when I have A plus n minus 1 into D, and I subtract D in order to get the previous term, I'm going to first distribute this. And I'll say A plus n times D is ND. And negative 1 times D is going to be negative D. Then I have minus D, which is this one, right? And then I can see that these two are like terms as well, right? So basically, I'm just going to be like A plus N D minus 2D. Do we agree? Because negative D minus D, negative 1 is going to give us negative 2. And now D is a common factor. So I will have what? A plus, open bracket, N minus 2 into D, which is the same as D into N minus 2. Do that make sense? So after taking out D as a common factor, the D will be outside. Therefore, I will have N minus 2. That's where the N minus 2 come from. Do that make sense? So I'm going to wipe this one and say, ding, ding, it has disappeared. Then I'm going to write it here, but with more space. Then I'm going to say, here I can have my A plus N minus 2 into D, close. Clear? And now, again, let me take it back. Now, I want another term that comes before it, right? So I'm going to take the current one that I just got and I'm going to minus D again. So which is going to lead us to the same process, which is what? A plus N minus 2 into D minus D. A plus N D minus 2D minus D, right? A plus ND minus 3D, because these two are like terms. Now I'm taking out the D as a common factor. I'll be left with N minus 3, which is going to be A plus N minus 3 into D. That's going to be our third last term. Clear? Then this one is also going to disappear and go like ding, ding, like that, right? Then it's going to be like, then I'm going to increase. Then it's going to go like, here it's going to be A plus N minus 3 into D. That's how we got it. So now you understand how they got the negative 2 and the negative 3, because sometimes students would be like, but Mr. Sir, how did they get the negative 3 and the negative 2? You just subtract D, but first you have to distribute the D of the last term into n minus 1 and then subtract the d to get the penultimate. Penultimate, which is the one that comes before the last, right? And then you're going to again do with that penultimate, you do the same thing until you get the second last, the third last. Okay. Now that you understand how they got this, we're going to go back and look at this term, and we're going to look at it like this and be like, the way it was, right? So we can see that on either side of this column, we have the number this side and we have the pattern this side, right? Now, when we prove this, it's not just about finding the n minus 3D and n minus 2D. No, it's not just about that, right, guys? What is it about? It's about finding the Sn. So I have to now write Sn again under the previous Sn, and then I'm going to swap all the terms, the first with the last and the last with the first, the second with the second last and the second last with the second, just like that. Meaning I'm gonna start from the last to the first. So let me start with the number so that you see what is really happening. I will first wipe here so that you can understand what is really going on. I'm gonna be like so that everything can be clearer and neat and right, so that it can look like you guys, it can look nice and clean and fresh. All right. Then I'm going to say, let me start with this. So I'm going to say S8 is equal to, right? So here I'm going to rearrange the previous pattern. This pattern here, I'm going to rearrange it. I'm going to start writing the last, then the second last, then the third last, just like that until the first in this order. But this time around, it's going to go in this way. All right. So while I'm doing that, check, right? Be careful. The last term will be in alignment with the first. The second last term will be in alignment with this, directly under. And this one will be directly under this one, just like that, until this one here will be under 23. So let's see. 23 will be the first one. And then 20 under 5, 20. And then 17 under 8, right? And then 14 under 11, right? And then 11 under 14, right? And then 8, right? And then 5, and then 2. You see, they are in alignment. And then obviously, if you add them, these are the same numbers. If you use a calculator, you're still going to get 98. You can add them, okay? So you're going to have 98, right? Then which is basically just the second step. And the third step is to add the two sequences now, or the series. So I'm going to say plus here and say vu, right? Which means I'm going to say S8 plus S8, which is going to be 2S8 is equals to. Now 2 plus 23, 25. 5 plus 20, 25. 8 plus 17, 25. You'll realize that every time when you add is 25. 14, 25. 17, 8, 25. 20 and 5, 25. 23 and 2, 25 equals to. Now when you add 98 plus 98, you're going to get 196, right? So you're going to get 196. Clear? So now you realize that all the terms now are exactly identical. And how many are they? 25 and 25, when you count them, is 1, 2, 3, they are 8. Which means I basically have 8 25s. Do that make sense? The number of 25 here are 8. So basically 25 times 8 is the sum of all the 25 when you count them, and they are 8. So this is basically me saying I have 2S8 is equals to 8, which is my number of 25s, my number of terms, multiplied by one of them, just 25, which was basically 196. Do you get the point? So I want us to stop here, or maybe we can go to the other side. Okay, I don't know. I'm indecisive. Okay, let's just continue with this one, right? So now you realize that when you have 8 times 25 equals to 196, you need to solve for S8, right? So you have to divide by the coefficient of S8. And even here, it means you divide all the terms by 2. You divide all the terms by 2 until you get what? We're going to say root 2. Until you realize that you have S8 is exactly 8 over 2 into 25. And when you calculate 8 over 2 multiplied by 25, you realize that the answer is basically 196 over 2, which is exactly 98. So the answer is just 98. You realize when you use this method, the answer is still literally the sum of all the terms, but we are using this particular method. Why am I teaching you these numbers? Let me show you when we do with when we're doing with variables. Variables come. Dango variables. So now when we are dealing with the variables, I'm going to do exactly the same thing. I'm going to start with the last so that it can be in alignment with the first. The second last will be in alignment with the second, and just like that. And then those that are in between, in the middle here, we're just going to write 3 dots because we realize that when we deal with numbers, they do also do the same. Do I make sense? They yield the same terms at the end of the day. So let me just write the second Sn. I'm going to say the second Sn, when I'm starting with the last term, it's going to be a plus n minus 1 into d. Then I close, right? Then plus, the second last is a plus n minus 2 into d. Remember, these are in alignment, right? And then the third is a plus n minus 3 into d. Then I close. Remember, this one is in alignment with these. Then it's plus 3 dots plus, right? And then now it's going to be this one under this, right? So it's going to be a plus 2d. And then now it's going to be a plus d. And then the first under the last, a. Clear? So you are just writing them from the last to the first, right? Now I'm going to just add them in alignment. Remember, a will add the first, and this one will add this, and, right? So I'm going to say plus, and say vuju, 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 right? Now, Sn plus Sn, guys, is how much? Sn plus Sn is 2Sn, which is equals to. Now, a plus n minus 1 into d. A and a. Let me show you on the side. If I have a plus n minus 1 into d, I'm just going to add the a's. It's going to be 2a plus, right? So I'm just going to say 2a plus n minus 1 into d. Then I close and I say plus, right? And then when I deal with the second terms as well, when I have a plus d, then plus this one here, a plus n minus 2 into d. How am I going to get this? Because remember, we had a lot of 25s when we were dealing with the values. So which means even on this one, I have to have the same terms, which means here I should have the same thing as this. But how? How is it going to be like that? Let's see. A plus a is going to give us 2a. Now, how do I add d to this? I have to first distribute this. I'm going to say plus d, then plus d into n, and d. D into negative 2, negative 2d. Now, d minus 2d is negative d. So I will have 2a plus nd, and d minus 2d is negative d. And then I can take out the d as a common factor. I'll say 2a plus into n minus 1 into d. Because I took out the d as a common factor, I'm left with n minus 1. Just factorizing. You see, this is the same thing as this. So that's exactly what was happening. Every time, distribute d into n minus 2 or n minus 3, and then deal with all the terms and like terms and stuff, and then take out the d as a common factor in order to see if it really gives you 2a plus n minus 1 into d. Come on, guys, this is easy, right? So let's see if the next term is gonna do the same thing. And it seems like it's going to do the same thing. So let's see. It's gonna be 2a plus n minus 1 into d as well. So now, do we agree that when you look at this 2, remember here I had 1d and negative 2d, right? Which means d and minus 2d will give me negative 1d. Even here, when you look at this, we have 2d minus 3d, so it's going to give us negative 1d. So basically, it's still going to give us the same thing. Come on, guys. So it's going to give us what? 2a plus n minus 1 into d. Basically, it's going to give us that until the last term. 2a plus n minus 1 into d. Because when you add this and this, the last term, when you go to the last term, when you add this and this, is basically you are doing the same thing that you did here and here, right? So let me clean it up. It's clean, right? So now that we see that all the terms are basically the same term, the same way we had 25 plus 25 plus 25. The question is, how many terms are there here? We don't know, because remember we are calculating Sn. It's not S8 or S10. It's n. The number of terms are unknown, which means if I just multiply all these terms by the number of terms, and number of terms is just n, basically I'll be removing all other terms. The same way I multiplied by 8 and removed all other 25s, and I said 25 times 8. Even with this one, I'm just going to say n times one term. Do that make sense? So let's see if it's gonna go down that way. So it's basically, I'm gonna say 2Sn is equal to n into 2a plus n minus 1 into d. Now I'm no longer gonna write all other terms. I'm just gonna write this particular one term. Does it make sense? Do that make sense? So when I'm writing only one term, which is this particular one term, then I know then I don't have to deal with all other terms. Like basically, it's like 8 times 25. N times this thing is like 25. Do that make sense? So now I can divide by 2 because I'm solving for Sn, and I can divide by 2 because I'm solving for Sn, and now I'll just say a little. Then I'm gonna say, therefore, remember they cancel, Sn is equals to, I wanna write it nice, so it's gonna be n over 2 into 2a plus n minus 1 into d. Then you close. Then that's the formula, guys. Remember, guys, I was just explaining. The reason why this video is long is because I was explaining every little thing so that you understand that, oh, this is where this came from. Oh, this is where this came from. But now that you understand, you can see that this can be easily done fast. How? You just write a, which is the first term. How did I get a plus d? Remember, if the first term is a, you just add d onto the first term to get the next one. You add d again to get this one. You just say 3 dots. You start on the last one with the general term. You subtract d to get the previous. You subtract d to get the previous, right? And then on this part, you do what? You rearrange. Basically, you're going to start with the last to be exactly under the first, then the second last to be exactly under the second, just like that, until the last one will be, the first one will be exactly under the last. And then you add basically. Do that make sense? You add this with this, you add this with this, you add, right? After adding with this Sn, it's going to be 2Sn because you're adding 2 Sns. Then you're going to multiply only one term by n so that you can remove others. It's like 8 times 25 because we had 25 eighths. Here we have n, a number of 2a blah 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 blah. That n is just n. It represents the number of those terms, right? And then you divide by this 2 on both sides, and then you have the formula. So you see, it's easy when you understand where everything came from. Guys, come on. You can't tell me this is difficult. As you can see, when you go back, you can see that was the formula that we were proving. As you can see, as it appears, you can see, and it's like that. And don't forget, guys, don't forget to do what? To subscribe and share. And remember to also comment. Guys, tell me what you would like me to do, which questions and concepts to break down for you, and just engage, because I want to talk to you, all right? But most importantly, I'm going to say it again. Please pray for my handwriting, guys. Ish.